Welcome back to In Depth with Academia. I'm Richard Price. I'm the CEO over at Academia.edu. And hey, thanks for joining me again. Today, we're diving into a paper by Boris Orikov that honestly just fascinated me the moment I saw the title. It's called You Shall Know a Piece by the Company It Keeps. Chess Plays as a Data for Word 2-Vec Models. Yeah, what a title, right? So let's take a deep breath and get ready to explore this academic rabbit hole because it's a wild blend of linguistics, chess, and machine learning. Now, let me just say, before I jump in, my job here isn't to tell you this paper is the holy grail or anything. I'm just going to walk you through Boris's ideas. Let's get right into the core question at the heart of this paper, because honestly, it's a fun one. Can we use the same tools we use to analyze words in language, like Word 2-Vec models, and apply them to sequences of chess moves? Does a chess move mean anything if you examine it by the company it keeps, just like we do with words? And why even bother, right? Well, the idea is all about seeing if the distributional properties that give words their meaning also apply to non-linguistic things like chess, because chess notations are kind of like language. They have structure, they express intent, and this is where it gets interesting for all of us. Even if you're not a chess whiz or an AI nerd, the real question is, when we use clever algorithms to look for context-based meaning, can we find actual patterns in something like chess that tell us about the nature of the game? Or are we just seeing digital shadows with no substance? Like, is a bishop's move to c4 more similar to a bishop's move to d3 because of how they appear in the text of chess games? Boris's approach is honestly pretty methodical. He takes a huge collection of chess games, think millions here, and treats the moves as words and the games as sentences. Then he applies Word 2-Vec, which is a very popular way to create word embeddings in computational linguistics. The central idea here is that words used in similar contexts tend to have similar meanings, so why not see if the same distributional logic applies to chess moves? There are actually two main approaches Boris tests. One is just looking at sequences of moves, as though they're words lining up across a page. The other, a bit more sophisticated, is looking at the actual positions on the board as context. So for every move, he records the placement of every piece, kind of like building a bigger, grander sentence that has both subject and setting. I find that pretty clever. Let's talk about some of the findings because, wow, they're kind of surprising. In the simple models, those with only moves, not board positions, the closest synonyms for a particular move are usually, wait for it, moves made by the same piece. This might sound obvious, but remember, the model doesn't know a rook from a pawn. It just knows what shows up with what. And Orikov does these fun tests, like if you look for the odd one out among a set of typical opening moves and sneak in a move that's usually only played in an endgame, the model actually picks the outlier. See, even using only the context of moves without position data, the system reconstructs meaningful clusters. Then, things get smarter when he brings board positions into the mix. The model starts seeing even more nuanced patterns, like being able to distinguish between early game and endgame king moves, or noticing that castling is unique because it always involves the king and the rook. There's this wild mirror symmetry in games without queens, moves made by black and white cluster in perfect balance. It's almost poetic, and if you're a chess fan, it kind of makes you want to see these visualizations for yourself. Oh, and digression time, this whole notion that chess notation might be language makes me wonder, does that mean there's poetry buried somewhere in a sequence of pawns pushing across the board? Or wait, is there a haiku game out there, all minimalism and hidden meaning? I don't know, sometimes my mind just wanders like that. Anyway, now I want to remind you again, I'm not endorsing everything in this paper, just giving you the goods as Boris presents them. He's clear in saying he doesn't see immediate practical value for chess engines or trainers from these models. It's more about the pure academic insight that in both language and chess, meaning emerges from context. The moves mean something by the company they keep. Why does this matter for you? If you're a chess player, maybe you start thinking about your sequences of moves in a new way. If you're into language, this reminds you that pattern recognition and context drive meaning not just in words, but maybe anywhere there's structure. If you love the messiness of academic research, like I do, it's a great reminder that insights don't always have to be useful right away. Sometimes it's enough to just notice a pattern and follow where it leads. So, what can we take away here? For me, it's that academic research is about exploring, about applying tools from one area to another. Even if, as Boris says, it doesn't make engines any better at chess. There's wisdom in testing the boundaries. And yeah, sometimes the company a piece keeps tells you more than you expected. That's all for today. As always, remember, research isn't absolute truth. It's an invitation to reflect, challenge, and play with ideas. Thanks for listening. Catch you next time on In Depth with Academia.